comes to geometric constructions, if you're asked to construct an angle KAB equal to 45 degrees, how do you do it? That is, you need to construct an angle and make it exactly 45 degrees. How do you go about this? Some students might ask this question. Some students might say, I'll just use a protractor to measure out 45 degrees. See, I measure 45 degrees here, mark it about here, and then connect the points. Isn't that 45 degrees? But others will point out that in geometric constructions, you're only allowed to use a ruler and a compass. This is what we call geometric construction. You're not allowed to use a protractor. Maybe you could ask the exam supervisor if you can get a VIP pass. If you had a VIP pass, maybe they'd let you use a protractor. So if you're not allowed to use a protractor, how are you supposed to draw it? If we're not allowed to use a protractor to draw a 45-degree angle, then how are we supposed to do it? Am I just supposed to draw it however I want? I can't just draw it randomly, right? If I just draw it any old way, I probably won't get any points, right? Drawing a 45-degree angle. Everyone, let me teach you how to do it. When you need to draw a 45-degree angle, you should think of a 90-degree angle. And when you think of a 90-degree angle, what comes to mind? An isosceles right triangle. What is this? This is an isosceles right triangle. Everyone. This angle here is 45 degrees. So on this segment AB, you need to draw an isosceles right triangle. Let's say this is 45 degrees, right? Then you need to draw an isosceles right triangle, don't you? So you see, drawing an isosceles right triangle isn't that hard, is it? We just need to find the midpoint. Look, we definitely need to find the midpoint of AB. How do we find the midpoint of AB? To find the midpoint of AB, can't we just use a compass and draw arcs as we like? Look, just pick a point and choose any radius you like, as long as it's bigger than the segment. Draw a circle, everyone. Just draw a circle. At this point B, just draw a circle with any radius. Draw a circle. After you draw the circles, there will be an intersection point above and one below, right? Everyone, there's a point above and a point below. Now, I'll connect these two intersection points. Isn't this the perpendicular bisector? Earlier, the point I drew wasn't accurate, so let's use this one as the standard. This is the perpendicular bisector, right? And this is the midpoint, correct? Okay, now that we've found the midpoint, the next step is to find a point C on this line. But where is point C? Here? No, that's not right. Here? That's not right either. I don't know where it is. It has to be a right angle. So how do we find a right angle? The method is the same. It's very simple. Take this midpoint as the center of the circle and draw a circle. When you draw the circle, what do you notice? You'll find there's an intersection point here, and that intersection point is point C. Why is that? Because everyone, the inscribed angle subtended by the diameter is a right angle, isn't it? The inscribed angle subtended by the diameter is always a right angle. Do you understand this principle? This is a right angle, and this is the perpendicular bisector. So this angle here, isn't it 45 degrees? Isn't this an isosceles right triangle? Didn't we just construct this 45-degree angle? You can't just draw it by measuring two angles, everyone.